All right, here we go. Problem number 4. Last problem in your notes. We are going to make some skateboards. Remember, on test day, this will be all set up for you just like it is now. And you'll be filling it in. Let's put some numbers in the chart, ready? Here we go. Total number of worker hours for production is 85. So production, total 85. There are 40 hours for finishing. Pro boards require 1.5 of production, pro production, and 2 of finishing. Specialty, get 1 hour of production and half of finishing. Profit on a pro is 50, and profit on a specialty is 65. All right, how do those numbers look to you? Remember, that's step 1. You have to be able to read the problem and put in the numbers into the chart. All right, what are we trying to maximize or minimize in this problem?
Maximum profit.
Maximum profit. So we're going to maximize our profit. And how do we calculate our profit? 50x
65x or y.
plus 65y. If we let x be pro and y be specialty, now we don't graph this, remember? Right? What do we do with this? This is at the very end. After you have all your points, this is where you plug them in. And the big one wins. All right, now what are my constraints? What's holding me back here? There's a constraint. 2x plus 1/2 y has to be less than or equal to 40, because I only have 40 hours. And then, what about this one? 1.5x plus y less than or equal to 85. And then we have the 2 that are always in there, but we've already graphed that because we're quadrant 1. So here we go. Now looking at the size of these numbers, I think I'm going to go back and use a scale of 10 again, like I did the other day. You can always change your scale to be whatever you want it to be. I think I'm going to go with 10, because those are big. Okay, so if I cover up y, it looks like x is 20, which is going to be 2 marks. This is 20 right here. And if I cover up x, y is, be careful,
80.
80. There we go. And that is shaded underneath because it's a less than. All right, now I'm going to cover up x. Y is 85, which there's 90, so 85 is gonna be right here. And then I'm gonna cover up Y. I'm gonna need a calculator for this. What's 85 divided by 1.5? So 56 point something, so it's 30, 40, 50. So like 56 point something. Whoa, this is unusual. And that one is also shaded underneath. So guys, what is blue and pink? Isn't it just this pink thing right here? Since the whole pink is inside the blue this time, then my overlap area is just right here. So what are my corners? 0, 80. There they are. There are the corners. So how do I figure out which is the best deal? Take each of those and plug them in right here. So 65 times 80. This will be 5,200. Guys, when I call for the quizzes, it's time to turn them in. You guys that keep them way past, not cool. All right, 50 times 20 is 1,000. So we have to advise our manufacturer what he should make. So what does it look like he should make? No pro boards. He should make 80 specialty boards. For a profit of $5,200. Now, you guys all are either have taken or are taking econ, and this is what the math would say. The math would say, make all specialty boards. But the reality is, what do you think? Should he make all specialty boards? No. He should probably make a few of the other kind. Even though his profit will be a little less, he'll be making more customers happy and maybe in the long run sell more, right? Because anybody who wants a pro board is not gonna come to his store, if that's all he does. Okay, get your homework out. Let's work through this homework problem together. So there's only one. So homework 7.5. Should be the last one in your little packet. Yep. If you don't have it, you'll have to get it off Canvas. We don't have time to wait around here. We got stuff to do. So the charts, this time the chart's at the bottom of the page. Looks like we got vitamin A, vitamin C, and cost per pill. We have brand X, brand Y, and minimum. vitamin A, where does that go? Jameson needs 4 milligrams of vitamin A, so his minimum need for vitamin A is 4. He needs 125 milligrams of C. Brand X gives 2 A's and 25 C's. Brand Y gives 1 A and 50 C's. How many pills each time should it take to meet the minimum requirement in the most economical way? Brand X costs 6 cents and brand Y costs 8 cents. How many pills should he take to meet the minimum requirement in the most economical way? What does that mean, most economical? So what does that mean, cost effective?
Most economical.
Cheapest, cheapest. Don't I want to minimize the cost?
Yeah.
So this is a minimized problem. So I'm going to do it the same way I did the other ones, but this time, instead of looking for the biggest output, I'll be looking for the smallest. And the cost is 6 cents for every X and 8 cents for every Y. So however many pills he takes, every X costs 6, every Y costs 8. All right, what are my constraints? Your rows are your constraints. So what does this say? 2x plus 1y greater than or equal to 4. Doesn't he need at least 4?
Yes.
He can have more than 4. All right, what about the next constraint?
25 plus 50
Yep. And of course, can't have negative pills, so we'll take positive pills. X and Y are both positive. All right, I'm gonna use a regular scale. If X is 0, Y is 4. And if Y is 0, X is 2. Now where's that shaded? Be careful, where's that shaded? That's shaded out. So all of this out here is shaded. Alright? What's 125 divided by 50? And 125 divided by oh, that's Y. That's Y. 2.5. That was Y. I covered up X. That was Y. And then X is 5. That was and that one is also shaded. So I am looking at this region right here that's shaded. So everything out here to the left, or to the right of this line, above this one, and in between here, that's what should work. Notice that the region is unbounded. There's no cap on it. I want you to think about this problem. Could this person take 100 of each kind of pills? He could, it wouldn't be smart, right? He might get sick or die. But all of these are options. He can take as many pills as he wants. We want to take the fewest number of pills that will keep us healthy. So we've got 0.4. I don't know what that is. I'm gonna have to figure that out. And I got 5 zeros. Those are my points. All right, anybody remember how we find that point? Okay, Cam, you got a new seat from now on, starting tomorrow, right here. All right, here we go. How do we do this? What do I do to solve that? I substitute or eliminate, yep, whichever you like best. I'm not gonna substitute, you can substitute. I hate substituting. So, I'm not going to substitute. No, I can substitute.
Yeah. Yeah, 'cause you can like make it line for one. Yeah. It's 45.
Okay?
Yep.
Now, let's figure out how many pills he should take. If he takes no X's, but 4 Y's, that's gonna cost him 32 cents. If he takes 1 X and 2 Y's, that's gonna cost him 22 cents. Put in 1 here and 2 here. 5 of these will cost him 30 cents. Oops, 30 cents. So what are we gonna tell Jameson to do?
1 brand X.
He should take 1 X pill
2 Y.
and 2 Y pills every day. For a cost of 22 cents a day. What, son? With X is 1. All right, now, no, if you are here today, you do not turn that in. It is due on Wednesday, but again, don't turn it in because you'll lose a point. So don't do that if you're here today. If you're not here today, you need to turn it in. All right, here come our practice tests. The moment we've been waiting for.
I'll be able to make it. When do you come back? So I'll be able to run it. No, it's Saturday, 1 p.m. I'll be there. Oh my, that is so good. There's no way.
All right, everybody get one? All right, let's get started. Here we go, practice test 1. I told you from the beginning that a page of your test would be substitution, elimination, and Kramer's rule. So, as much as I do not like substitution, I'm going to have to do it on this problem because that's what the directions say. So here we go. You go ahead and get started. See if you can remember how to substitute. Make your life easy and pick the letter that's already by itself. If you pick any other letter up here, you're going to have to do a division. And that may or may not result in fractions. Why do that? Don't do that. So x equals 7 minus 2y. Plug it in right there. So here's what x equals. I'm plugging it in right there. Onto my distributive property. I'll collect like terms. Subtract 14 and divide by -5. I got y equals 2. And then what do? Plug it back in anywhere you want. I like to plug it in here, but you can put it in wherever you want. Put it into it looks like x is 3. And then if I have time to check, if I put a 3 here and a 2 here, I should get 4, shouldn't I? And I didn't. So I think we're right. Now we're going to eliminate. Which means we're going to add and something's going to cancel. So we're going to have to make that happen because nothing's going to cancel now. So maybe multiply this row by 3. So our top row is the same. And then our bottom row times 3 all the way across, all the way. So 11x equals -11. X equals -1. So we have to put in -1 somewhere for x. I got 2. And then of course I can always check that. I plug in -1 and 2. I do it and get -5. Good job. Okay? Solve using Kramer's rule. That's what you just quizzed over. So when I grade that problem, I will be looking for 3 determinants. That's what I need to see. Because that's how Kramer's rule works. So, the first one I'm going to see is 2, -4, 3, 2.
Multiply and subtract.
So that's going to equal 4 minus -12. I got 16.
Yeah.
then I need a, determinant for x and y. So I'll put 1, -2 in for x. Y stay the same. 1, -2 in for y, and the x's stay the same. Watch your signs here. This is 2. This is 8. But I'm subtracting, so it's actually 2 minus 8. That's -6. And -7. So what do I put in the answer blank? -6 over 16, which I'm gonna have to reduce. -3/8.
Yeah, -7.
And -7 over 16, which does not reduce.
For X and Y, you add them, you don't subtract them.
2 minus 8.
Why is that?
As a
Oh.
negative times a negative is a positive. All right. 2, and now we're doing a whole page of matrix operations. All right? Here we go. 2a. What are you gonna write down in the answer blank for 2a? Oh my gosh. 2.
Oh, 2 times,
4,
yeah, just
6.
multiply by 2.
-2, 2, 0.
Yeah.
0, 6, 2. It doesn't count if I have to tell you. You guys gotta figure this out. 2a, that's easy. Everything times 2. B
Just subtract them.
minus C. I'm gonna subtract them if I can. Can these 2 be minus C? Can these guys be subtracted?
No.
Yes, because they are the same size. Right? They're the same size? So here we go, item by item. 1 minus -1.
2.
-1 minus 1. 2 minus 0. 3 minus 2. There it is. A plus B, this is problem C. A plus B. Can't do it. Why not?
Because they don't have the same dimension.
They're not the same dimensions. In order to add or subtract, we have to have the same dimensions. All right, we'll stop there. We do not have time to do a multiplication. Stop right here.